Good afternoon, everyone. Thanks for coming to my talk. My name is Ming Ma. I'm the dev manager of Hadoop team at eBay. We are doing platform improvement as well as service support at eBay. So today I'm going to give an overview about how Hadoop has been used at eBay, as well as some of the lessons we have learned in making Hadoop more available. And last, I will talk briefly about the opportunities we see moving forward. So as a global commerce leader, eBay has lots of data about users and merchandise. And it generates tons of data. And here is a brief summary about the key data set we have at eBay. As you can see, we have different type of data. We have transactional data, we have structured data, we have unstructured data. And this data is very valuable to eBay. And folks in the company were looking into a system that allows people to do machine learning and data mining at large scale. And that's how Hadoop gets started. Around 2007, when the first version of Hadoop came out, a couple of folks in eBay Research Lab set up small clusters with 10 nodes. And since then, we have seen tremendous growth over the years. From 2011 to 2012, we are seeing the job throughput growth by more than 200%. Until we get to 2013, we have one of our biggest clusters in the world running Hadoop with tens of petabytes of storage and tens of thousands of cores running. We have more than and running thousands of jobs every day. In addition to running shared cluster, or you can call it multi-tenancy cluster, we also have shared cluster is primarily used for analytics, and it supports a mix of ad hoc jobs as well as production jobs. On the other hand, dedicated clusters is primarily used for business critical applications that have direct business revenue impact. And if we look at the job type distributions, we can see that more than half of the MapReduce jobs are written in Java using MapReduce framework. There's also other type of jobs. For example, Hive, Pig, Mobius. Mobius is a framework platform that eBay developed. It allowed developers at eBay to use eBay dataset effectively. It provides a Java API as well as query language. So in some sense, it's a little bit like Hive, except it's used for eBay dataset. And let's walk through a couple interesting use cases here. The first one is Cassini. I think some of you might have heard about it. This is a full rewrite of eBay search engines. It put the raw data into HBase, and it runs MapReduce jobs, take HBase as input, and generate inverted index. The inverted index will be shipped to index serve nodes for online queries. So in this case, the search engine is using HBase as input and run MapReduce job on a regular basis, and it provides output. So it's a back-end processing systems. It has very strong SLAs. One type of the job they are running is called near real-time jobs. This type of job runs every 10 minutes, and it has to finish within 10 minutes. So That's why we call this Cassini scenario have very strong SLAs on Hadoop. Because of this reason, it is running in dedicated clusters at eBay. Another use case are item recommendations. Those are pretty common use case for Hadoop. For this type of job, they use a bunch of different data sets at eBay, including transactional data and then the click logs to do data mining and using the regular recommendation machine algorithm to do that. And it's running in a shared clusters. It's a production job, but it doesn't have a strict SLA as Cassini. Another interesting case we have is the idea is to provide a dashboard for business analysts and program manager to use to understand the trend at eBay, like how people are using eBay.com, the items, the popular items over time. Actually, there are different teams doing dashboard analysis on the top of Hadoop. One of the common paradigm is you run a regular MapReduce job on a daily basis. You summarize and aggregate the data, and you push the output to HBase. And then you have a different web application that access HBase to provide real-time queries. Now, for any application to work, data is very important. So eBay Hadoop data platform, it's a multi-layer system built on top of Hadoop systems. It provides consistent abstractions on eBay dataset. At the bottom layer, all the raw data are stored in HDFS, including structured data and unstructured data. And on the top of that, you have metadata layer that describes the raw data, such as the schemas, the type, etc. For the data to be consumed by different applications, the data first has to be ingested into Hadoop clusters. So the data ingestion pipeline is used to copy the data from the source, such as the web server log or the transactional database, into Hadoop. And after that, people will use different high-level programming language, such as Hive and Pig, to access the data. And there's a bunch of tools we develop over time to make the monitoring support much easier. Now, over the years of running Hadoop at eBay, we make many improvements in making Hadoop more reliable and easier to manage. At the platform layers, like HDFS, MapReduce, and HBase, we fix many reliability problems and many features we added into Apache over years. In addition to reliability improvement, we also make some enhancement in Hadoop security. The default implementation of Hadoop security doesn't work at eBay infrastructure due to the specific infrastructure setup at eBay. We add the multi-ream support, and in addition, we also add encryption support into Hadoop. Besides working on Hadoop 1, we also spend effort looking forward into Hadoop 2, which we plan to deploy in the near future. So as part of the effort, we are making lots of improvement in make sure that it is binary compatible, so that when we upgrade our cluster from Hadoop 1 to Hadoop 2, the existing MapReduce jobs can run without any problems. Automation is very important at eBay. We have very big clusters, and supporting supporting the big cluster in a cost-effective way is very important for us. So we spend quite an amount of effort in looking into how we can automate operations. And one idea and one thing we have done so far is how do we automate machine decommission and recommission process. So in HDFS, if you have machine failures, such as the disk failures, the machine needs to be returned to the vendors. And then once it has been repaired, you can return back to the Hadoop clusters. And in the last couple of years, we have made tremendous progress in this space so that there's no human involved in this process. It's fully automated. That significantly reduced our operation costs. In addition to operation automation, the user-facing or data management is also very important. At eBay, we run production jobs under production account or batch account. Those accounts are not specifically tied to a specific users. Instead, it's tied to specific products. And so we need to provide a provisioning service that allows different teams to manage their account in a self-service manner. And that actually greatly reduces our operation costs as well. So no matter we are running a production analytics job in shared cluster or running business critical application in a dedicated clusters, availability is very important to us. So next, I'm going to give a brief overview about the lessons we have learned in these areas. Now let's first look at a couple outages we have in our clusters. The first type of outage is caused by the defective applications. Back in 2012, we have this incidence where a test applications actually caused the production HBase MapReduce job to time out. If we do a root cause analysis, we found out that these test applications create have a very heavy write load into HBase. And HBase is very busy doing the flushing, and it takes up all the HBase RPC thread. And when the application MapReduce job came later, it cannot be served because all the RPC thread has been used. So eventually, the production HBase MapReduce job timeout. Similar thing happened to HDFS name node. We have actually more than one incidence like this, where an application doing something that it's not supposed to do. For example, it creates lots of small files under map task, and this generates huge amount of traffic and RPC call into name node, and the name node RPC call just get queued up, and as a result, the data node heartbeat cannot get into name node, and then name node start to think, okay, all the data node are dead. It start to the repair process, and the replication storm happened after that, and the whole cluster has to be restarted as a result. Just like a defective application can cause cluster to be unavailable, platform bugs can also cause problems. When I say platform, it's not just HDFS. It includes other layers, such as operating systems and Java's JVM machines. And when I say bugs, it's not just code bug. It's also configuration bugs. So I give some examples here, where in Hadoop part, we I think also back in 2012, we have this problem where job tracker JVM need to restart once every 2 weeks. So we do some debugging and analysis. We figure out that there's a thread leak in job tracker. A second example in Hadoop is about configuration bug. In HDFS, there's a parameter you can control how much bandwidth you use for replications. This is used when you're trying to balance the cluster, as well as when you're trying to decommission nodes and recommission nodes. And it turned out that the definition of this parameter is megabytes per second. It's not megabit per second. So in our configuration, we mistakenly set the value assuming it's megabits per second. So set it to be a pretty big value. And what happened is when we have a rack failure or when we have lots of machines being decommissioned, the network bandwidth usage spike and cause the cluster unusable. JVM can also have cost problems. I think in 2012, lots of companies run into this problem in JVM bug. It's a leap second bug. As a matter of fact, all our clusters are down around the same time. GC setting in Hadoop is also very, very important. We make some mistakes early on to use different GC algorithm. And if we don't choose the right GC algorithm, what happens is name node is going to run into full GC every so often. When name node is in full GC, name node is not going to respond. And the cluster is not usable as a result. On the OS layer, the same thing happened, that kernel can have bugs. And in fact, we run into this bug every so often in all our clusters. Machine get reboot. Name node get reboot. Zookeeper get reboot. HBase region server get reboot. All this has an impact on the system availability. In addition to unplanned outage, cluster maintenance is another source of availability impact reason. There are a couple of scenarios here. The first one is co-rollout. So we are talking about 1.2 to 1.3, for example. When you do the co-rollout, how do you do it in a way that the cluster is not down? The cluster can continue to provide service. We cannot do it today in Hadoop 1. First of all, name node is a single point of failure. If you want to upgrade name node, you have to shut down name node and start it. Secondly, we have this problem with RPC compatibilities. So when you upgrade, if you just want to upgrade data node, then the protocol has to be compatible so that the newer version of data node can continue to talk to the older version of name node, for example. In addition to co-rollout, configuration change. It's very common for us. We change configuration from time to time. Sometimes it's because we are increasing the cluster size. As a result, we need to adjust some of the parameters to make it work. For example, if you increase the cluster size a lot, you have to increase the intervals of heartbeat sent from task tracker or from data node to reduce the impact on name node. So we need to make configuration change. Now, in Hadoop, in task tracker, in data node, each time you make a configuration change, most likely you need to restart the JVM. Right. There are certain configuration change you don't need to restart the JVM. For example, if you change the queue setting on the job tracker, you don't need to do that. But for most part, you have to restart the JVM. And then people will say, okay, now let's do a rolling restart on the job tracker, on all the data node and task tracker. What happens is if you do rolling restart, you are going to kill the task. And it will have an impact on the job latency. Now, in some case, you also cause job to fail if you don't do it right. The next scenario is machine recommission. So from time to time, we have these machines that get decommissioned a long time ago. and we want to add it back to the clusters. What happened is the Hadoop version running there was pretty old, and the OS running there was pretty old. And we added to the clusters without knowing that, and it caused problems. Right. So cluster maintenance, it's a very interesting area that some people might ask, why should that be considered an impact on availability? So it's very important for us to clarify what's the definition of availability. Now, from eBay perspective, we believe cluster maintenance should be included because it impacts customers. So on high level, availability is defined as uptime divided by the sum of uptime plus downtime. Now, what's considered downtime here? Downtime here includes the planned maintenance as well as unplanned outage. And the way we measure our system availability is using a synthetic transaction approach. So we look at HDFS as a black box, and we submit regular MapReduce jobs, work count job, on a regular basis. And we check whether the job can finish in time. If it cannot, then we think the cluster is not available during that period of time. So it's pretty straightforward. But it turned out that there's a lot more to it. First, I want to say is that availability, 99% or 99.5%, that numbers is different from what many people call mean time to recover. Imagine there are two scenarios. One is the cluster is down 1 day every 100 days. The availability will be 99%. Another case is the cluster is down 40 minutes every day. The availability is also 99%. Now, for certain applications like Cassini index build, the MTTR is more important than availability. The second question is, what is considered available? Right? If the performance degrades, for example, if the MapReduce job latency increase from 5 minutes to 15 minutes, is that considered the cluster not available? Suppose HBase write throughput job, is that considered unavailable? Right? So it's a little bit vague here. The second one is, if we use our original approach to submit canary job, work count job to check the system availability, it just submit a single MapReduce job, and most likely it only run one map task on one data node and task tracker. It's not going to be able to figure out whether the clusters have lots of machine failures. For example, the whole rack failed. The canary job cannot detect this. So the number of nodes that are live are also very interesting for some folks. And in HDFS and MapReduce, there are many data entry points you can use the service. People sometimes use web UI to check their result. What if the web UI layer of HDFS stops working, but the underlying job tracker and name node are still running? How do we account for the availability on that? The next question will be, okay, now how about the data set availability? Right? Suppose someone, some data pipeline didn't get run in time, the data is in Hadoop is not available. The platform is fine, but the data is not available because the jobs that produce the data didn't get run for some reason. Right? So for some customers, this is very important. And the last case will be multi-tenancy scenarios. In a shared cluster, some customers have different view about availability than the others. And how do we provide a fine-grained per customer's base availability? is also tricky. So our general recommendation here is we have the baseline to capture the overall cluster availabilities. If we need to go to fine-grained one, we will go to fine-grained one. So for example, we can have HBase availability, we can have Hadoop availabilities, and we can have data set availabilities. Right? So we can have different metrics to capture different scenarios. All right, so a lot has been done in open source to improve the Hadoop availability. And at eBay, we have also made several improvements. Now, instead of going into the detail of what open source have done and what eBay have done, I would go over some of the common techniques and principles used in building reliable distributed systems and see how they apply to Hadoop. The first technique people often use is automation. If you use automation, it can reduce the chance of human error. In our cluster, we use Puppet for deployment. We use Daemon 2 to do process supervision. And monitoring is also very important. If we have a good monitoring story, then we can detect the problem quickly, and it can reduce our failure time window. If you combine the automation, the deployment automation and monitoring automation, we can even come up with something very cool. For example, we can do incremental deployment and then do the monitoring in the back end. When we figure out the incremental deployment has problem, we can do rollback if necessary. Right? Redundancy is another common technique used. It has been used a lot in different systems. Hadoop used that a lot. In Hadoop 2, name node HA is basically a solution to provide redundant name node. So that if one name node fails, the other one can just take over. We can apply the same ideas to region, to HBase, region server. In the HBase design, the actual data stored on disk has 3 copies, but the data in memory only has 1. Suppose we change HBase design so that the data in memory actually have 2 or 3 copies, so that if one region server fails, the other backup standby region can just take it over very fast. Isolation is another technique we have seen people use. HDFS federations is an example. You can put HBase related data into one partition and click log into a different partition, so that suppose you run into a problem with HBase, it doesn't impact the other applications that are not using HBase. I know Yahoo has done some work in the region server case, which they provide grouping for region server. That's another way to do isolation. Congestion control, it's a technique that has been used in TCP. The idea is that you have lots of client requests come in. You want to make sure that your keys service are not being bottlenecked by a specific client. So there's work being done, and we are doing some prototyping here to put a traffic congestion control into the Hadoop RPC layer, so that no single client can cause denial of service on name node and region server. In addition to all these different principles, there are a couple features, ideas we could do to make Hadoop more available. For example, imagine if the Hadoop JVM task tracker data node can support dynamic configuration update, so that each time you update the configuration, it doesn't need to restart the process. It can pick up the configuration and keep running. That would be really good. RPC compatibility has been done in Hadoop 2, and this is very useful for us to do rolling upgrade. Can we do a better, smarter rolling restart? so that we can minimize the chance of task failure or job failures. As a result, it can reduce the impact of job latencies. Right? Now, as Hadoop continues to evolve, the demand of Hadoop service at eBay continue to grow. Our customers, the number of customers are growing, the cluster size are growing, new use cases emerge. So next, I will briefly go over some of the opportunities we see moving forward as an adopter of Hadoop as well as an innovator on Hadoop. The first one is automation. So we just have to keep doing it. We have a big cluster. Our cluster size is going to get bigger. We have to enable automation so that our support costs can be minimized. Availability and scalability are very important for eBay. And one of the ideas we have is to put everything into one big clusters, for example. So the platform reliability is very important if we want to do that. Multi-tenancy is another case somewhat related to our strategy of putting everything in one big shared clusters. Now you start to run into a problem of running production job with strong SLA with ad hoc jobs. How do we tackle that? How do we provide quality of service at Hadoop and HBase layers? Can we leverage what OS provides to provide a better story of quality of service? The last are new scenarios. We want to make Hadoop more accessible to a broader audience so that, for example, data analysts and program manager can use Hadoop using SQL language in an interactive fashion. They can do reporting, they can do ad hoc visualizations. So interactive query is something we are very interested in. Another scenario is to make our current developers increase their productivities. What happened today at eBay is you have developers who use Hadoop. For that, they have to go to intermediate machines in order to get access Hadoop. Now, what if we can provide direct access so that the developer can just use Hadoop directly from their dev box? So that will be very, very cool. And we have some prototype working. We are trying to deploy to our production cluster soon. So to sum up, Hadoop adoption at eBay has come a long way. And we believe this is just the beginning of an incredible journey. And I think that's it for my talk. Thank you. Any questions? Can you go to the mic, please? Yeah.
I have a question. Do you see any advantage in using shared storage for your clusters?
Shared storage, meaning that instead of directly using local disk.
That's right. Right now you're using the white boxes with the spindles, right?
That's right.
DAS.
Yes.
You have to distribute your workload uniformly across spindles.
Yes.
If you were using shared storage, LUNs are already striped at the array. You will have better performance with shared storage than you're getting with DAS.
I don't think so. Now, we have pretty big scale at eBay. We have lots of data. I don't have data to prove that, but my intuition is it's probably not the case. But we can discuss more if I'm wrong.
We can discuss more.
Okay.
Thank you.
Sure.
Hey, You said you have all your data in HBase, right? So if you want to open it to users to query it, how do you do it? You create a Hive table which is managed by HBase or something like that? Or how do you open it if you want to do it?
Our biggest data set is not in HBase. HBase is used for some specific application at this point, like search index build. That's, the data is big, but it's not the biggest in our clusters. And your question is how the data in HBase.
How do I do it? Do you just go to HBase cell, or you go provide any means of querying the data if you want to retrieve some information?
Oh, people just go to HBase shell to do the query and write application on top of that.
All right, thanks.
Yeah.
When you open the Hive or SQL-based interface to Hadoop, to all the project managers or salespeople, they consider this Hadoop or thing as like a traditional data warehouse, and they start to run queries like scanning 2 months or 3 months. Like how do you handle those kind of multi-tenancy problems when people don't know much about Hadoop, but they use SQL interface?
Okay, that's a good question. We haven't run into the problem yet because it's not running yet. That's the new scenario we need to enable. Yeah, that's a problem we need to solve, is how we can support different type of workload coming into a shared clusters. And one idea would be we should leverage Hadoop 2 Yarn framework so that it can manage the resource in a more effective way.
Thank you.
Thank you.
First, thank you. That was a very good presentation.
Thank you.
You mentioned about developers getting direct access to Hadoop. Could you elaborate a little bit more on that? I'm curious, whether you are exposing Hadoop protocols or you are introducing some unified protocol.
Okay. There's a security constraint here at eBay where if you want to allow developers to access Hadoop directly from their development box, the communication between their development box to Hadoop name node has to be encrypted due to eBay security requirement. So the work here is mostly about let's make sure that the communication channel between that box and Hadoop name node are encrypted. At the same time, the communication between Hadoop name node and data node are not encrypted. So we need to change some Hadoop code to enable that.
Okay, great. Thank you.
Thank you.
Hi, I have a two-part question. So regarding the size and scale, how large is your environment, like as far as the number of nodes or clusters or the data size is concerned? And the second is, do you have the HBase instances on the same clusters as HDFS, or do you have separate clusters for HBase and HDFS?
Yeah, that's a good question. So our cluster size, we have 2 big clusters. Each one runs a little bit less than 2,000 nodes. Yeah. Regard how we co-locate HBase with Hadoop layer, for some critical applications like Cassini, we have dedicated clusters. For our shared cluster, HBase with Hadoop. Now, we don't run HBase on all the nodes. We only run HBase on 10% of the nodes.
Okay.
Right.
Okay, thank you.
Hi, it was a nice talk, and I have a question. Like when you talked about like pushing a new patch to your cluster, let's say, how are you doing? Like, are you at any point of time, like if you are pushing a patch to HDFS, you need to restart your name node, right? So when you are restarting your name node, how are you tackling the workload or like traffic? So do you have a separate, like switching name node, or like how are you dealing that situation?
Yeah, today we don't, for code rollout, we just shut down everything. We don't do rolling restart because Hadoop 1 doesn't have good support on that. When we come to Hadoop 2, our plan is to use Hadoop 2 name node solutions as well as the RPC compatibility so that we can do rolling restart on name node as well as data node. We haven't done it yet, but that's our plan.
Okay,
Yeah.
thank you.
Thank you. Yeah.
How do you have a view of the number of MapReduce clients that access the Hadoop cluster Is that of something interest to you? Like, do you monitor who's accessed the Hadoop cluster, and do you run any metrics on that?
Most people access Hadoop clusters using MapReduce jobs, and we have statistics about the type of different jobs running in the clusters. If that's your question. So, sorry, I think we are running out of time. This is the last question. Yep, go ahead.
Sure. Now, when you have multiple stakeholders accessing the cluster, do you charge back?
Oh.
How do you manage that? Okay.
We don't charge back.
Thanks.
Yeah, thank you. All right, thank you.